You guys, there's a warm-up question there, another system of equations. We haven't done one like that in a while. So, check it out. We'll talk about it here in a second. If you don't remember how to do it, just wait. Last day of September. So this warm-up question is similar to the one we did yesterday with systems of equations, where we have two variables and two unknowns. But this one, it's all lined up, but nothing would cancel. Like if you guys remember yesterday, Ellie, I think, had told us we just add them together and those variables canceled out. This one's slightly different. It's not going to cancel if I add those equations together. If I add them, I get y and y, which is 2y, and I add the 3x and 2x, and that's 5x. So now I just have more x's and more y's. Does anyone remember how to do something like this? We learned it in algebra, but it's probably almost a year ago that you probably learned it, probably back in midway through algebra. It's kind of hard just to guess and check because I actually think the numbers are kind of big for this one, I think. Yeah. Now you could do that. So Allie suggested we, just because of muffled, she said that you can multiply each equation by something to make something the same and kind of get something to cancel that way. So you could multiply one of them by -1 maybe. That would work. It would probably not be the most efficient way. Kind of similar to geometry, where two things equal the same value. If I know y equals 3x minus 80 and y equals 2x minus 5, what do I know about those two? They both equal y. This is just substitution here, you guys. If this is y, can't I just put that in place of y? So can't I just replace the y with 3x minus 80? So I can just substitute that in, and we kind of did that in the geometry problems we've been doing. So I can substitute that 3x minus 80 in for y, and that's going to equal 2x minus 5. So I got down to just a single variable with just that one step. And then I'm able to solve it. Now, Allie's way would work. It's just maybe not the most efficient, but if it's what she saw and it worked for her and she got it, that's fine. It's just this one's probably a little faster. I'm not saying it's the best way. It might be the most efficient way, but if she sees it and it works for her, that's fine. I think Nolan, solved it another way as well. From what I can tell, looks like he got an answer that makes sense. Because 3x minus 2x is just 1x, or just x. And so x is going to end up being 75. Is that what you got too? And you had solved it kind of with the adding, right? Is that what you ended up doing? Oh, you did do it that way. Okay. So I'm not saying so with Allie's way, you could multiply this by a -1 or subtract these equations. That would also work. Or you can multiply this one by a 2 and this one by a -3. That would also work, but this is probably the most efficient way. And then again, once I know what x is, I still have to go back and find y. So I would put this back in, probably, I guess maybe not in that one, but I put in the lower one. So the numbers are smaller. What's 75 times 3? 225. And then what does our y end up being? 145 or 135? 141. Okay, thank you. Oh yeah. So these have been really hard numbers to come up with just by guessing and checking. So hopefully you have some sort of method to get to that answer. This is something that I'm just kind of reviewing with you guys again. Like my Algebra 2 students just did this lesson. They just did systems of equations. And most of them are pretty rusty on it because they'd only saw it a little bit maybe in geometry, if at all. And so it's good to review some of those algebra topics. Actually, in the next couple of weeks, we're going to be taking kind of like just a test to see where we're at in terms of all our algebra skills, to let me know what I need to review with you guys over the course of this semester. So just a heads up on that, that'll be coming. There'll be a kind of a test just to see where we're at. But so what we're learning today is actually not really all that different than what we learned yesterday. So hopefully today's going to feel like kind of a little bit of a review, kind of make sure we're all in the same place as one another. I questioned like putting two lessons together just because I don't think this lesson's going to take us super long. And I think, oh, I grabbed the wrong thing. I don't think it's going to be too complicated a lesson, but I think that's okay on a day when we have like ACP and this homecoming week and got stuff going on. So, all right. So basically what we're learning today is that what we learned yesterday, that if lines are parallel, angles were either congruent or they were supplementary, we're going to learn that the opposite of that is also true. So that if I have congruent angles, then that means the lines are parallel. So it's kind of a way to prove lines are parallel. So these are going to seem like really similar rules as we talked about yesterday. So do you guys remember what the rule was with corresponding angles? Were they equal or supplementary? Corresponding angles. Just to remind you guys, corresponding are like in the same position. So those are equal. Sorry, I just gave it away. I marked it. So if corresponding angles are equal or congruent, and I'm going to use some symbols just so that we have a little bit of space. So make sure you're okay with all the symbols. I don't think they're too crazy of symbols. So if corresponding angles are equal, then lines are parallel. So if I have two corresponding angles that are equal in a drawing, I can automatically assume those lines are going to be parallel. The next one, similar idea here. Alternate interior angles. Remember, those are the, I always think they kind of make like a Z shape, a little zigzag. So if alternate interior angles so then you're going to feel like we're basically learning the same rules today. And it's just kind of, it's the converse of that. So it's just that I can flip that statement and it also works. Now, consecutive interior angles. What's the rule of consecutive interior angles? That's the one oddball. What's true of consecutive interior angles? They're supplementary. Those are the ones that add to 180. They're kind of on the same side there. And then our last one is the alternate exterior angles. And those look like this. So what we're going to do today is some of the questions are going to ask us, are these lines parallel, and how do we know that? So if you look at the drawings down on example 1, all of those lines look parallel. But I'm going to tell you that they all are not necessarily parallel. So we're going to see if there's enough information to know if those lines are parallel or not. So this is going to be yes or no, and then if it's yes, how do we know, and kind of know why not. So making sure that we're aware that based off of what we see in our drawing, is that enough information to prove lines are parallel. So again, A and B in all of these cases look parallel. I think I actually used the same drawing again and again, so that was intentional. Do I have enough information to prove that A and B are parallel? So do I know that A and B have to be parallel in this case? And if you say yes, you're going to have to tell me why. If you say no, you're going to have to explain why. So either way, it's not just a yes or no. So I'm seeing some head nods. I saw some people write yes. So if yes, why? What do you think? Yeah.
Because there's corresponding angles, so they have to equal 180. Not corresponding, consecutive.
Yeah, and I know the wording is, we're still getting used to that. So since 1 and 2 equal 180, so they gave us that information. We have, consecutive angles, which is almost like corresponding. Consecutive that are supplementary. So since we have that, that proves that those lines are parallel. So yes. So consecutive angles that are supplementary proves those lines are parallel. So this would be yes. And so in your homework, you're going to just have to do a quick description. So that's not a complete sentence. That wouldn't even really make sense if I went over by an English teacher if I said, what's consecutive supplementary? But you guys know what I'm saying. You can add the extra words in if you want. But we have those consecutive angles that are supplementary. If you want to do some abbreviation, I'm okay with that. Just know that I want you to know the word consecutive versus corresponding. So making sure that you kind of know the difference between some of those. All right, how about letter B? So letter B, just so you guys know, these are supposed to be like the little arcs. So they tell us that these two angles are equal. They tell me A and those two little angles are equal. And you might be like, they don't look equal. They say they are, so we have to assume they are. Is that any of our rules? No, there's no rule that says these two should be equal. Now, some of you guys might be saying, well, I know those two are equal. Then I know these two are equal. But there's no rule that says these two are equal. So we don't have enough information in this case. So this one is no. Right, Kate is doing a minus over here. This might get lost here. Oh, wait. He wants to help me. Oh, wait. Okay, I don't need help. All right, so no, because basically in this case, there's no rule that says that these angles have to be equal in order to those lines to be parallel. So this one's a no, we don't have enough information, okay? So down to letter C. So they tell me those two are 110. What kind of angles are those? Vertical. We call those vertical angles. Are there any rules that tell us that vertical angles are equal, we have parallel lines? No. You're right that vertical angles need to be equal. But this intersection could look like anything. I'll draw you what this could look like. The fact that the lines look parallel sometimes is confusing. So this is 110, this is 110. That other line, that could look like this. That could do anything over there that we don't really know what that B really looks like. I mean, obviously my drawing can't make assumptions. So even though those are both 110, there's no rule about vertical angles. And some of you guys might be trying to say, well, if this is 110, that's 110. We don't know that. There's nothing that tells us that because these lines aren't necessarily parallel. So this one is a no. There's no rule about vertical angles. So I just wrote vertical angles don't prove parallel. Now you don't have to write this big long definition or reason or anything like that. I just want, if you look back at your notes, like why didn't that work? Well, it's because of the fact that vertical angles aren't any of our rules. So the 4 rules that we learned at the top are really the only 4 rules we can use. Now this next one, take a minute to think about this one. This one might take a couple steps maybe to make sure it works or doesn't work. Look at this one, decide what you guys think here. All right, what do you guys think? Yes or no? Luke's nodding yes. Anyone else? Anyone disagree? All right, why yes? Because right now I look at that and there's no rule that are, because these are technically like consecutive exterior angles. There's not a rule for that. So how did you figure it out? Yep.
Because the 110 is vertical angle, we want, and the 70, the angle to the left of the 70, we 110.
Oh.
Is equal 180, and the 10 and 10 are.
Or this way too, right? There's a lot of different ways now. So I like Luke used a lot of different rules here, and like you could have used a lot of different explanations. So he used vertical angles, he used a linear pair, and all those different things give us enough information to show us we have a whole bunch of 110s there, and we could figure out a whole bunch of 70s. But since we have those angles on different intersections, we're able to make those conclusions. So this one is yes, and really it just depends how you went about it. At some point, you're using vertical angles for sure, and probably linear pairs maybe. But those then would imply that we could use alternate interior angles corresponding. You could have figured out this was 70 and these two are consecutive interior angles. So there's a lot going on here that we could use. So very good. Like this one probably would have a ton of different explanations. Like last year, I think we used vertical and consecutive interior angles, but it's really, I mean, like, yeah, we know a lot about this drawing. So that one does work out okay. All right, so I think we're gonna take a break. And we can, so again, we're gonna just go for our little nature walk outside.